Writing formulas for covalent compounds, very, very easy. This won't give you any trouble whatsoever. Um, let's let's start off with a sample on this actual slide here. Let's say you come across dinitrogen monoxide. Oops. I need to learn how to spell. Alright, dinitrogen monoxide. Write the symbol for each element in the order given. Alright, so it looks like we have nitrogen. And oxide is just oxygen. And a binary covalent compound is composed of two nonmetals. We see it's nitrogen and oxygen. Look at the prefix of each one. So nitrogen has a di prefix. So we go over here and we see that di means 2. So we're going to put a 2 on the end. And then mono means 1. Well, we don't write a 1 because I've already taught you that 1s are understood. So there's the formula for N2O for dinitrogen monoxide. We don't have to worry about charges here. There are no ions involved. There's no crisscrossing, nothing like that. You just have to know these prefixes, know what they mean, and those are the subscripts. So pretty straightforward. So carbon dioxide. Well, carbon dioxide has obviously C and oxide, O. We don't see anything in front of carbon. One of the things we'll learn when we write names is that mono never goes on the first element. So if you don't see a prefix for a binary covalent, then you know that it's 1. So I'm not going to write the 1. It's understood to be 1. And then we see a di in front of oxygen. Di means 2. So there's CO2, our answer for the first sample. Diphosphorus pentasulfide. All right, we have phosphorus. And we have sulfur. And we see di is in front of phosphorus, so that's 2. And penta is in front of sulfide, so penta means 5. So P2S5 is the answer for the second one. I think this is really, really easy. So tetrasulfur heptaoxide. So we're going to have sulfur, S. We're going to have oxygen, O. Tetra, that means 4. Hepta, that means 7. So S4O7. Carbon monoxide, again, if you don't see anything on the first element, and it's a covalent compound, you do not need to assume it's anything but 1. It means 1. So C is the first symbol, O is the second symbol. We notice that mono is on the second word, so that means it's also a 1. So we have CO. Hexacarbon, hexahydride, carbon and hydrogen, that's hydride means hydrogen. So CH, hexa means 6. There's a hexa on both words, so C6H6. And then dihydrogen monoxide, hydrogen is the first element, oxygen is the second element. Di means 2, so there's going to be a 2 on the H. And mono means 1, so yes, that would be water, H2O. That's just, so this is just a fancy name for water, dihydrogen monoxide. So remember, binary covalent, you know they're going to have 2 elements, and both elements are nonmetals. Hydrate is kind of a combination thing. You have an ionic compound, and then connected to the ionic compound, you have a certain number of water molecules attached to it. The template, in other words, the way that each one's going to look, is you're going to have an ionic formula, and you're going to have a little dot or asterisk, and then an X H2O. Now the X represents the number of water molecules to ionic compounds you have in the hydrate. So it's real easy to identify the number by the prefix. And the ionic formula is written normally. Let's do some examples here. I already have the answers written there. Magnesium sulfate heptahydrate. Well, hopefully you'll see automatically that hydrates are easy to identify in their names. They all end in hydrates. And the first half of it, you know what, let's go ahead and get all these in black. And then we'll switch over to pencil. Magnesium sulfate, if we just saw magnesium sulfate without the heptahydrate, we'd say magnesium is +2, sulfate ends in ATE, so that means it's polyatomic, so we have to look that one up. So SO4, they add up to 0. So this would be our answer if it was just magnesium sulfate, but we have this heptahydrate on there. So we have a little asterisk or dot. Sometimes you'll see this written like that, and actually it's a little lower. We see hepta, so that's the 7, and then hydrate, we just throw an H2O in the end. Very straightforward. Copper 1 chloride, well, by itself, copper 1 chloride. Now I taught you earlier that the Roman numeral 1 means +1. So copper's +1. Chloride, we know, is a monatomic ion because it ends in IDE, so it's just one element. So Cl. And chloride or chlorine is a halogen, -1 charge. +1 and -1, they cancel out. So there is the formula for just copper 1 chloride. But then we have this decahydrate. Deca means 10. And then the hydrate part, we put H2O on there. And last one here, barium phosphate trihydrate. So if we were just doing barium phosphate, barium is +2. It's an alkaline earth metal. That's its charge. Phosphate, we know it is a polyatomic ion because of the ATE ending. So we have to look that one up. It's PO4. Has a -3 charge. +2 and -3, do they add up to 0? They don't, so the 3 goes there. The 2 crisscrosses. I taught you when you crisscross a 2 to a polyatomic, you need the 2 there for the parentheses there for separation. So there's our ionic part. And you have this tri, so that means 3, and hydrate, H2O. So barium phosphate trihydrate. Hydrates are pretty easy to identify and to write the formulas for. You can actually heat these and get rid of the water, and it becomes what's called anhydrates. Basically what that means is these are, when you heat them, you're getting rid of all this. And what's left is just the salt. So if you take magnesium sulfate heptahydrate, which is basically Epsom salt, and you heat it, you dehydrate it, and you make it an anhydrate. But a lot of anhydrates will sometimes over time just naturally absorb water back in and become hydrates again. So it's a very loose, this little asterisk stands for a very loose chemical bond between the ionic part of the hydrate and the water itself. So that's part 6. Part 7 is coming soon.